Hi everyone and welcome to the section of grade 9 CBSE physics class. I am Nitish S. And today we are looking into the chapter of physics grade 9 first chapter that's called motion. Chapter 1 is motion. To study motion, we have to study first the concept of motion and the concept of rest. That means the basic part of this chapter is what the concept of motion and what the concept of rest. Starting with the same topic, I'm going to deliver the difference between motion and rest. First, we can go through the concept of motion. If an object changes its position with respect to time, then the object is said to be in motion. That means when time goes on, if the position changes, then the object is said to be in motion. That means if we are considering this an object just here, when I am looking, it's now just here in this position. But after some time, again I am looking if this object takes this position. Then we can say that the object changes its position from here to here. That means this object changes its position with respect to time. If this happens, then we can say that this object is in motion. If an object changes its position with respect to time, then the object is said to be in motion. That's the concept of motion. If an object changes its position with respect to time, then the object is said to be in motion. This is what called the concept of motion. An object changes its position with respect to time. Time is the basic quantity with respect to time. Then the object is said to be in motion. Now we have to consider the concept of rest. What do you mean by the concept of rest? I'm now going to the concept of rest. In motion, we are saying that the object is changing its position with respect to time. That means as time goes on, the object changes its position. But in case of rest, the object which we are considering is not changing its position. The time goes on, the object remain in its previous position. That is in a fixed position. If we are considering this as an object, I'm just placing it here. When I am looking at this object, now it's in this point, in this position. But after some time, Again, I am looking, the object remains in the same position, not at all changing. Again, after some time, I am looking at the same object and it does not changes the position. Now also here, the object remains in the same position. That means when time goes on, the object does not changing its position. It is remaining in the same position. It does not changing its position. Then the object is said to be in rest. That means if an object does not changes its position with respect to time, here also the basic quantity is time. If an object does not changes its position with respect to time, then the object is said to be in rest. If an object does not changes its position with respect to time, then the object this is the concept of rest. If an object does not changes its position with respect to time, then the object is said to be in rest. This is what the basic thing in the chapter motion. The concept of motion and the concept of rest. In motion, the object is changing its position with respect to time. But in case of concept of rest, the object is does not changing its position. Now, I think it's clear to you the concept of motion and the concept of rest. Now, moving directly to the chapter, we are discussing different topics in the chapter. First, we are starting the main topic in the chapter, the difference between scalar quantity and vector quantity. First, we are discussing what a scalar quantity is. A scalar quantity simply means those quantities having only magnitude. Magnitude means value. That is, these quantities does not have any direction. They are having only magnitude. That means we are representing these quantities, or we are saying these quantities, or we are writing these quantities just in value only, not mentioning its direction, or it does not have any direction. They are having only magnitude. That means they are having only value. We are writing only its value. No need of a direction. Such quantities are called scalar quantities. We can say that scalar quantities are those quantities having only magnitude. They are having only magnitude. That means they are having only value, no direction. We need not to mention the direction of these quantities as they are having no direction. Since this quantity is having only magnitude and no direction, it cannot be zero or negative. These quantities cannot be zero or negative. They are having only positive values. They cannot be zero or negative. It is because we said that these quantities does not have any direction. They are having only magnitude. Magnitude means only value. The values, like for example, 1, 2, 3, 4, etc., like any number values. It cannot be zero or negative values such as -1, -2, -3, etc. because they are having no direction. The negative sign in a quantity represents its direction. Here, it does not have any direction. Therefore, we need not use any negative sign or zero value. Therefore, we can say that these quantities cannot be zero or negative. We can take the examples of these quantities for the quantities which cannot be zero or negative. That means the quantities which are not zero or negative are all examples of scalar quantities. That means, for example, we can say distance is a scalar quantity. Speed is a scalar quantity. Time is a scalar quantity, and etc. etc. There are lots of quantities. For examples, are scalar quantities. Now I am writing only three: distance, speed, time, etc. You can take other examples also, which cannot be zero or negative. Now look, distance, speed, time, etc. In distance, we are representing its magnitude only, not direction. It does not have any direction. And look, the second example, speed. This quantity also having positive values only. They cannot be zero or negative. Now the time. You all know that we are representing time only in positive values. We never take time as negative or zero values. Therefore, these all are examples of scalar quantities. Simply, we can say the quantities having only magnitude are called scalar quantities. Now moving to vector quantity. Now let us look what a vector quantity is. Vector quantities. In scalar quantity, we represent or define the quantity as the quantity having only magnitude. They are having only magnitude, no direction. But in vector quantity, this quantity can have magnitude as well as direction. Those quantities having both magnitude and direction are called vector quantities. Since this quantity can have direction, this can have zero and negative values also. That means vector quantities can take all values, zero, positive or negative. Now we can define the vector quantity as those quantities having both magnitude and direction.